here. We're going to do the first three. Okay, we'll look at the first three today. So 6.2 is talking about determining volumes by slicing. Okay, so um, today we're just going to talk about the disk method. 6.2 has something called the disk method and the washer method. We're just going to talk about the disk method today. In essence, what we have here, y'all, if you look up here at the picture, we have this kind of a function here that they're using in this kind of maroon line. And we're looking at this on an interval from A to B. And what we're doing is we're rotating it about the x-axis, okay? And so what we end up getting is we kind of get like almost like a cone, right? It's a cone that has like the bottom part chopped off. You know what I mean? So what we say is, look, if we wanted to find the volume of this thing, what we're going to do, y'all, we're going to make little tiny circles that look something like that's a pretty coarse circle. We're going to make little circles that are going to look like this, right? Where this here is the radius. Those circles are going to be really, really, really thin. They're going to have a small thickness of a change in the x that we call that little dx, okay? So, guys, ever since we were kids, your first experience with money for the most part is change, right? So if you think about dimes, they're pretty thin, right? Have you ever seen those machines like at, what is it, like or the museum or where they crush them, right? You can put your penny in there and it makes it really, really, really thin, like it flattens them out. You ever seen this before in the museum? You can put like a penny in the thing and then you got to put like 50 cents and you turn this wheel, right? So you just spend 51 cents. Yeah, and it takes your penny and it flattens it out. So it's now, like really, really thin. Think about like, you're rolling a tortilla, right? And you want to have your tortilla like super, super, super thin. That's kind of the idea. What we're going to do here, y'all, we're going to find the areas of these circles, or the volume, I'm sorry, of these circles. And these circles are going to be super thin, right? So think about it like this. It's going to be like this with just, the slightest thickness, okay? So it's like a Riemann approximation, right? So it's kind of like we're adding up. Remember how we did those little rectangles with the area? We're kind of doing the same thing here. Y'all, this here, what I have is a cylinder. The volume of a cylinder is pi r squared times h, okay? So that's my r. My h, y'all, is the thickness of the cylinder. So it's going to be pi r squared dx, because my cylinders are going to be super, super, super thin. The amount that it changed was from that x value to that x value, and it's like infinitesimally small, right? Super, super tiny. Okay. So if you notice right here, since the volume of a cylinder is pi r squared h, or the area of the base times the height. Okay. All right. So I have a little theorem right here. The way we're going to find our volume by disks, y'all, is we're going to find the volume of a solid revolution rotated by the area under the graph of f from A to B, and it's going to be pi times the integral from A to B of f of x being squared times dx. The f of x is always going to be my radius, okay? So let's see if we can figure out how to do the first problem here. And I'm going to walk you all through the process just so that you get an idea. Okay, it says, find the volume of a solid obtained by rotating the region bounded by y equals 7x squared, x equals 1, and y equals 0 about the x-axis. Okay, so look, y'all, first thing I'm going to do, I'm going to try to draw a picture. So I'm going to say right here, that's x equals 1. This is my x axis, y'all, my y-axis are not going to be the same scale. 1, 2, 3, 4, 5, 6, 7. Okay. So this here is my graph of y equals 7x squared. Okay. Now, what we're going to do is we're going to rotate the region bounded by y equals 7x squared, x equals 1, and x equals 0. So x equals 1 is going to be this vertical line right here, y'all. That's the vertical line, x equals 1. Okay. I want to show you the area that we're talking about. This is what we're looking at. Okay. What we're doing here, y'all, is we are taking this region here and we are rotating it about the x-axis. So it's going to rotate like that. Okay. I want you to think about what would happen. If this was a piece of paper, y'all, and I could fold it about this line, wouldn't I get like a mirror image like that? Right? If I could fold it about that line there. Okay. So this is kind of what we're looking at here. Okay. What we're going to have, y'all, we're going to have circles. See if I can make that circle a little thicker. We're going to have circles that are going to look something like that. Okay. And we're going to find the radius of that circle. The radius of that circle is going to be the distance from there to there. Well, the distance from my x-axis to the graph is just 7x squared, right? Because it's the y value, right? What's the y value? Well, whatever it happens to be at that x value. So look, y'all, my radius here is going to be 7x squared, okay? Now, we're going to have a bunch of those little circles. Now, remember, we talked about how do I find the volume of the cylinder? The volume of the cylinder, y'all, is always going to be pi r squared times h, okay? So in this case, it's going to be pi r squared. Look, if my r is 7x squared, wouldn't my r squared be 49? X to the fourth, okay? 49x to the fourth. Now, the thickness of that circle, y'all, is that real infinitesimally small thickness of dx, okay? So look, we're now going to integrate. We're going to integrate from this point here to that point there. So this is from 0 to what number? To 1. So from 0 to 1, I'm going to leave the pi outside of 49x to the fourth dx. Okay. So this is going to be equal to pi. Now, we're going to go ahead and find the antiderivative. Does anybody know what is the antiderivative of a 49x to the fourth?
49x to the fifth divided by 5.
Very good. 49x to the fifth divided by 5. And again, y'all, we're evaluating this from 0 to 1. Okay. So everybody agree the first time we're going to plug in a 1? Okay. 1 to the fifth, anybody know? 1. Times 49? Over 5? Just like that, all right? Okay. Guys, what happens when I plug in 0, though? We get 0, right? So minus 0. So my answer here, y'all, is going to be 49 pi over 5. Now, y'all, I want to say that in my open math, I'll put it this way. So from my perspective, right, from the teacher perspective, when I click on this little deal right here, it gives me the answer, right? And I'm sure it gives you the answer if you got it wrong, it tells you what it is, right? I don't know if I'm going to assume that if you plug in that, it's gonna be okay. It does, when I click the little thing, it always gives me the decimal approximation, but you can find the decimal approximation by taking 49 times the little pi button and dividing it by 5. But I think we're good right there, okay? In all of these problems, y'all, the first thing we're going to be doing, we're going to be drawing a picture. We want to draw the graph so that we can have a visualization of what it looks like, because we want to know what are we rotating about. And for the first few problems here, y'all, we're rotating about the x-axis. The other thing is we are looking at finding those limits of integration. And when I draw the picture, it's easy for me to find my limits of integration, okay? But my formula is always going to be based on this formula right here, y'all, that the volume of the cylinder is pi r squared times h. I'm always going to base it on that part, okay? So look, let me walk you all through another problem, again, just to make sure that we're getting the idea here. So look what it says. It says, determine the volume of the solid generated by rotating the function 1 divided by the square root of x about the x-axis bounded by x equals 9 and x equals 10. Okay, so the first thing I'm going to do, I'm going to draw a picture that's going to look probably something like this. Now, y'all, we're going to do this from x equals 9 to x equals what? 10. Okay, so look, I'm just going to do this right here. I'm going to put a 9. Over here, I'm going to put a 10. Now, I'm going to say that right there is the number 1. If I plug in the number 9 into this function right here, if I were to find f of 9, that would be 1 divided by the square root of 9. That would be 1/3, wouldn't it? So 1/3 is about, well, 1/3 the way up. Okay. If I were to find f of 10, that would be 1 divided by the square root of 10, which is, oh, I don't know. I'm going to take my calculator. 1 divided by, I'm sorry, what did you come up with, Steve? 3.16. Like this? 0.316, right? 0.316. So isn't that a little bit lower, right, than 1/3? Because 1/3 isn't 1/3 point a whole bunch of 3's, and 0.316 is just a little bit lower. Okay, I want you to think about what I have here, y'all. Look at, if I connect those 2 points, that's what I have. Okay. What we're doing now is we're going to rotate this about the x-axis. So the first thing I'm going to do here, y'all, I'm going to draw a little line connecting those points. And since I'm rotating this about the x-axis, I want you to think about if I could make the x-axis like a little dotted line, and if I could fold my paper along that dotted line, wouldn't we then have something like this? Right? Because that's the mirror image. It's kind of like that x-axis is kind of like my mirror image. Okay. So now I want you to think about what we're going to do, y'all. We're going to draw these little discs. We're going to draw these little circles that are going to look like this. Okay. Now the radius of the circle is from the function to the x-axis. So the radius of my function is going to be the distance 1 minus the square root of x, right? We need to find the radius being squared. So the radius squared, isn't the radius squared 1 divided by the square root of x all squared, which is just 1 over x, right? Because I'm squaring everything, so the square root of 1 is still 1. The square root of the square root of x is just x, okay? Now, if y'all recall, those circles, y'all, they're really kind of like little cylinders, right? Where the thickness, the height, is that real small height dx, right? How do we find the volume of the cylinder? It's always pi r squared times h. So in my case here, we're going to have v equals pi r squared. R squared is my 1 over x, right? 1 over x, and my height is dx. What we're going to do now, y'all, we're going to integrate this thing. We're going to integrate this thing. Look what our limits were. Our limits were from 9 to 10 of 1 over x dx. Now, y'all, it's been a little while since we've seen this antiderivative. I'm going to give you a hint here. I cannot use my power rule, okay? I can't use the power rule on this one. The power rule works as long as my exponent is not a negative 1. And in this case, my exponent is a negative 1. Does anybody remember what the antiderivative of 1 over x is? If you don't, that's okay. I'm going to see if I thought I put it in the formula sheet, but I don't know. I'm going to check right now. Yeah, that's what I'm saying. We can't use, yeah, it doesn't work that way. But remember, it's x to the negative 1, John. Very good. There you go. Say it again. Natural log of x. Boom. Let me get my pen going here. Here we go. This is going to be equal to the natural log of x. Very good. Natural log of x with my pi, don't forget, from 9 to 10. So this is going to be pi times the natural log of 10 minus the natural log of 9. And there's my answer, right? Very good. Very good, yeah. So the antiderivative of 1x, y'all, is the natural log x. Awesome. Very good. Glad you remember that. That's one of those that we want to kind of keep using the power rule, but the power rule works, y'all, as long as my power is not a negative one, and we got a negative one, so we can't do it.
Isn't, when you write like natural log of 10 minus natural log of 9, does not equal natural log of 10 minus
10 over 9.
10? No.
10 over 9, yeah.
Does my life have to say
You wanted to. All right. So look, y'all, I got one more problem that we're going to do here, and then again, we'll do this problem, y'all, and maybe we'll do one more. I just want to get the idea of making sure that we know what's going on here, and we'll see if we can't figure this thing out. So it says find the volume of the solid obtained by rotating the region bounded by y equals 7x squared, x equals 1, x equals 4, and y equals 0 about the x-axis. Okay, so first thing I'm going to do, y'all, I'm going to draw a picture. Okay, so here's my picture. Here's my x-axis, my y-axis. Okay, I'm going to do it like this: 1, 2, 3, and 4. And I'm not going to do this so that it's to scale, y'all, because it's just not going to work that way. My graph would be way too different. 7, 14, 21, 28. There we go. Okay, so here's my graph. Now, y'all, I do have the other side of the graph going like this, but I want you to notice which part we're bounding this thing by, right? So we're bounding this by x equals 1 and x equals 4. So look, here's x equals 1. That line right there. Here's x equals 4. This line right here, right? So the part that we're really rotating, y'all, is this piece right here. Okay? We're going to rotate that about the x-axis. All that means, y'all, is that I want you to think about your x-axis as you're folding it across that line. Okay? So then, what would the second half of my graph look like? It would look something like this. And what we have now, y'all, we have these little circles that go like that. And there's my radius, right? There's my radius right there. So again, remember, the radius, y'all, is always, in this case, going to be whatever my function is. So my radius here, y'all, is a 7x squared. Okay, there's my radius, 7x squared. All right, let's see, what else do we have? We got 7x squared. Okay, so my radius squared. I got to square my radius. What is 7x squared when you square it? 49x to the 4th. Okay, so remember what we're doing here. We're finding the volume of little cylinders right here. Okay? So the volume of the cylinder is always pi r squared times h. So it's going to be pi r squared, what he said was 49x to the 4th. Our h, y'all, my h is always going to be my dx. Very good. Okay. So now we're going to integrate this thing. So I'm going to leave the pi on the outside. We're going to integrate 49x to the 4th dx. We're going to integrate this, y'all. Look at what the limits we're using now. From 1 to what? 1 to 4. There you go. Okay. All right. So first question. Anybody know what is the antiderivative of 49x to the 4th? There you go. Here's my pi. And again, y'all, we're evaluating this from 1 to 4. Okay, So let's see. Let's do this slowly. So what I would probably do here, y'all, I'd probably say, what is 4 to the 5th power times 49 is 50,176 over 5 minus, when I plug in 1 to the 5th is still 1, times 49 is still 49 over 5. Here's my pi. And then I would just subtract those two numbers. I would take 50,000 minus 176 minus 49, and I'm coming up with 50,127 with a pi all over 5. And we got it. All right. So let's see, y'all. Let's see. I think there's 2 more here to do. Let's see. I'll tell you what. Let's hold off on these 2 here, and we will do them next week. We only got 2 more problems to do. I want to save them so that we kind of next month or next week we will kind of do a little review, and by doing these problems, it's kind of reviewing the volume stuff again. So we'll hold off on these last 2 problems. So y'all, just to give you a heads up, let's see, there's 2 more questions, but let me do this. If I come back to Gilio here we go. And here we go. Okay, so 6.1, y'all, is due on the 27th. 6.2 is not due until the 2nd. I want to say out of 6.2, if you click on it, there's only 5 questions, okay? There's only 5 questions on there. So right now, you should be able to do the first 3, okay? So you don't worry about 4 and 5 if you want to, but the first 3 you can do. And 6.1, I think there's only 4 questions. There it is right there, okay? So we did those already. Okay, so y'all, just a friendly reminder, on Wednesday, what we're gonna do is we're going to review for the test, right? So again, y'all, if you come back over here, here's the review for the test. Let's see. There should be 40 questions on here. Yeah, 40 questions. You can start, right? It's all right there. And the test, y'all, will open up on Wednesday. So if I click on it right here, it'll tell me, hey, it's not open yet. It'll be open on Wednesday, right? Guys, question. I want you all to look at the formula sheet for test 2, and I have it right here. So between today and Wednesday, you guys, if there's anything that you think that I need to add to the formula sheet, do me a favor, tell me on Wednesday, okay? So, oh look, by the way, there it is right here. Remember before I was saying, what's the antiderivative of 1 over x? It's the natural log of it, right? Like which one? Oh, properties of logarithms. So, if there's anything in here, y'all, that y'all think needs to be added in, the only reason I don't add the properties of logarithms, I mean, is, what was it? Here. That's all you're using it for, is that right there, right? Does it make any difference if you write the natural log of 10/9 or the natural log of 10 minus the natural log of 9? You know what I mean? So, guys, again, if there's anything that I want y'all to do me a favor, take a look at this stuff. And again, guys, the one thing I would say, if there's any place for me to add anything, I think it would be in here. You know what I mean? Like if there's any spot, if there's any place for me, like, oh, should I include anything else? I would say like, I would think it would be in this part. Like, do you guys want, and the reason, I'll put it this way, y'all, the easiest way for me to think about it is, and again, one thing I want to mention, y'all, when you're taking your test, obviously you're going to be able to do this from home. You're going to have all your resources, right? But like one thing I could see people saying is, well, you know what? How do I know what's the derivative of, if I see like a particular trig function, right? How do I know what's the and I'm trying to find the integral. How do I know what the antiderivative of that is? And my suggestion would be, well, look, if you look at the first formula sheet, right? And suppose you're trying to integrate a secant tangent. Well, then you would say, well, the integral of a secant tangent would just be a, right? Or if you see, and again, and I don't think you're going to have anything like this, y'all, because we never did this, you know what I mean, throughout class. But if you saw something like, well, look, if I was integrating a negative cosecant squared, what would it be? Oh, it would be a cotangent. You see what I'm saying? Because remember, the antiderivatives and derivatives, they're going back and forth, right? But if there's anything that you do want me to add to the formula sheet, y'all, guys, please tell me. I'll be more than happy to make whatever changes I need to make. Guys, I will upload the formula sheet up here as well. And if there are any changes, like if you guys have any changes for me, I'll update it. I'll throw it in there so that you have like the most updated one. So again, guys, Wednesday, what we'll do, we'll answer any questions out of the review. And then, y'all, the test will open up Wednesday at the end of class. So it'll be available at 2:50 on Wednesday. It's not due until the 27th, right? You get your 2 shots, all that kind of good stuff. I don't know why it has this stuff here. Edit. I don't know why it has this part here. Okay. So anyway, and then guys, just a friendly reminder. I think it's up here. I think I put it in this deal here. That next Monday you won't have class, right? That's me giving you the day to take the test. So a week from the day, guys, don't show up here because you'll be here by yourself. But that's me giving you the day to take the test. I mean, you can come in here if you need a quiet place. Come in here and take the test. You know what I mean? But we won't have it. We won't have class that day. Okay. So what do you think? Good stuff. Great. Okay. Again, y'all, we won't have the stuff on chapter 6. What we did today is not on this test or anything like that, right? So don't sweat it so much. That's why I put the deadlines a little bit later, because I really want you guys to focus on the review. Again, especially if you haven't had a chance to do too much of it between today and Wednesday, try to do as much as you can so that on Wednesday, when we go through it, you can say, okay, look, I got stuck on this one. I got stuck on that one. But we'll go through as many questions as we can. Again, guys, I'll record it. I'll upload it to YouTube so you guys will have that reference as well, okay? Yeah. Okay. Sorry, guys. So that's it for us today. Let me go ahead and stop recording.